The next thing we're looking at is the MTC, the trim factor. And MTC is abbreviation for moment to change trim 1 centimeter. It's a factor that depends on the vessel's size and shape. The unit is ton meters per centimeter, and it means how big trimming moment does it take to change the trim 1 centimeter. In other words, how many centimeters do you have to move 1 ton in order to change the trim of the vessel 1 centimeter? And we'll look at some examples. MTC is found in the stability data for the vessels, like here, a deadweight scale, where we see all the way at the right we have the trim MTC, or you can find it in tables such as this one, where you have it in the right-hand column. When you do calculations, we use the following formulas. Change in trim equals trim moment divided by MTC, and trim moment is the weight that is moved multiplied by the arm, the distance you move it, divided by MTC. Okay, so we are moving 10 tons 30 meters aft on this vessel. The MTC in this case is 5 ton meters per centimeter. And the change in trim as we move this box, 10 tons by 30 meters, that gives us 300 ton meters. Divide that by an MTC of 5 ton meters per centimeters, we end up with a change in trim of 60 centimeters aft. So the trim changes 60 centimeters more aft as we move this. This means that the draft aft increases with 30 centimeters and the draft forward decreases by 30 centimeters. Another example, we have a vessel that shifts a weight of 10 tons 15 meters astern. The vessel's MTC is 17.2 ton meters per centimeter. So how much does the trim change as we move the box? Well, we move the box and we do the calculations. Weight by arm, that's 10 tons by 15 meters, which gives us 150 ton meters. Which means that the change in trim is 150 ton meters divided by 17.2 ton meters per second, which gives us 8.7 centimeters of change in trim. And so in this case, the ship trims just underneath 9 centimeters more aft as we move the weight. So 4.5 centimeters of increased draft aft, 4.5 centimeters of decreased draft forward. Next case, you shift 8 tons from the aft deck to the foredeck, a distance of 29 meters and an MTC of 6.7 ton meters per centimeter. The draft before you shifted the box was forward 3.2 meters and aft 3.9 meters. And what will be the draft forward and aft after you've done the move? Okay, we move the box, we see the trim changes. Trim moment in this case, weight multiplied by arm, 29 meters by 8 tons is 232 ton meters. And the change in trim, 232 ton meters divided by 6.7 ton meters per centimeter equals 35 centimeters. Which means when you divide that by 2 that you have 17.5 centimeter less draft aft and 17.5 centimeter more draft forward. So you end up with a draft aft of 3.72 meters and a draft forward of 3.38 in this case. Another example, and this time from the small fishing boat Skårungen, which has an MTC at 0.181 ton meters per second. And we shift 1 ton from the aft part and all the way forward, a distance of 8 meters. So the question is, how much does the trim change and which way? Well, first we calculate the trim moment, weight by arm. 1 ton by 8 meters equals 8 ton meters. Then we divide that by the MTC, which was 0.181 ton meters. So we end up with a change in trim of 44.2 centimeters. So we see that the trim will change by 44 centimeters if we do this movement of this weight, which means again 22 centimeters less draft aft and 22 centimeters more draft forward. Another example, on our way home from Lofoten, we shift 200 kilograms of small anchors from the forward part of the boat to the aft part. The MTC for this displacement is 0.192 ton meters per centimeter. And again, the distance of approximately 8 meters. So the trim moment in this case, 0.2 multiplied by 8 equals 1.6 ton meters. And the change in trim, we end up with 8.3 centimeters. And as we move the weight aft, then the trim changes aft, which means that we have 4 centimeters less draft forward and about 4 centimeters more draft aft. We're going to look at how we can find the longitudinal center of gravity based on using the table method. Now, when we distribute weights on board in a vessel, we use the table method in order to find the LCG after loading and discharging. And the way we do this is exactly the same as in transverse stability, except that we don't use the vertical center of gravity for the weights involved, but the longitudinal center of gravity, so which is in most cases distance from the aft perpendicular. So we are putting on some different cargoes on this vessel here. We put up the table here where we see the ship before loading. We have 4 different cargoes with their weights. We have the longitudinal center of gravity both for the ship before loading and for the different cargoes. And we have calculated the longitudinal moments. We summarize the weights and we summarize the longitudinal moments. And the new longitudinal center of gravity is the sum of longitudinal moments divided by the sum of weight. And in this case, we end up with 18.06 meters. So then we have calculated that the new longitudinal center of gravity is there. And we can use the longitudinal center of gravity to find the trim and draft forward and aft after loading. And this is how we do it. The longitudinal center of gravity we have calculated using the table method. We found out that it was there. The longitudinal center of buoyancy is the center in the part of the hull that is submerged underwater, and this is found in the stability data for the vessel. The MTC is how much moment to change trim 1 centimeter. This is also found in the stability data. And the BG, the distance between the longitudinal center of buoyancy and the longitudinal center of gravity, we find by subtracting the one from the other. And the bigger this distance is, the more trim we will have. So if G is in front of B, then we have forward trim. If not, we have aft trim, and you have to look at which one is bigger, LCG or LCB, in order to determine which one is the case. In order to find the trim, we use this formula. Trim equals trim moment divided by MTC, which equals BG, the distance B to G, multiplied by displacement, divide that by MTC. So that's how you find the trim. We have calculated a longitudinal center of gravity that is 26.2 meters. From the stability tables, we take out a longitudinal center of buoyancy of 26.94 and a moment to change trim of 8.12 ton meters per centimeter. Displacement at this draft is 940 tons. What will the trim be and what will draft forward and aft be when the draft amidships is 2.9 meters? So we have the G and the B, and this gives us a BG, LCB minus LCG of 0.74 meters. Since G is astern of B, we know that the trim will be aft, and we can enter this into the formula. Trim equals BG multiplied by displacement divided by MTC. Crunch the numbers and you end up with a trim of just under 86 centimeters. Aft trim, since the G is astern of the center of buoyancy. Then to divide and find the draft aft and forward and aft, we have to use this formula. Draft aft with aft trim, we have the draft midships plus half the trim, we end up with 3.33 meters. Whereas draft forward is draft midships minus half the trim. which gives us 2.47. Next example, we have calculated that we have a longitudinal center of gravity of 27.13 meters. From the stability tables, we take out the longitudinal center of buoyancy of 26.94 and an MTC of 10.4 ton meters per centimeter. The displacement is 1,031 tons. What we want to do is we want to find the correct trim. So we know G, we know B, we know the MTC, we want to find the trim. BG in this case, LCB minus LCG equals 0.19 meters. Put it into the formula and we find that we have a trim of 18.83 centimeters. And since G is in front of B, we will have a forward trim of about 19 centimeters. Use the formula and then we can find the draft. We can also go the opposite way if we want to find the LCG. That means that we start out with draft forward and aft, we find the trim, we calculate the BG, the distance BG, and from then on we can calculate our way on to the longitudinal center of gravity. And we use the same formula, and then we turn around so that we have the BG on the left hand side, so that it looks like this. BG equals trim multiplied by MTC divided by displacement. Now remember that the trim is in centimeters. You have to put in the trim in centimeters, whereas the BG is in meters. LCB, that we can take out from the stability tables, and then we can easily find the longitudinal center of gravity. And we will look at an example. Draft forward is 3.2, draft aft 3.6. What is the longitudinal center of gravity? We have a draft midships or middle draft of 3.4, and with that draft we take out a longitudinal center of buoyancy of 23.1 meters. The MTC is 15.2 ton meters per centimeter and the displacement is 960 tons. The trim is 40 centimeters aft. So we use the formula, we put in 40 centimeters, multiply that by 15.2 ton meters per centimeters and divide it by 960 tons, which gives us a BG of 0.63 meters. And within aft trim, you have G behind B. So then we have an LCG equals LCB minus BG, 23.1 minus 0.63. So we have an LCG, longitudinal center of gravity, of 22.47 meters.